Probability distributions and expected value. So the first thing we need to talk about is really what is just probability. Probability is when you have the number of events divided by the number of total outcomes. So say if you had a deck of cards and you wanted to draw 4 aces, what is the probability of drawing 4 aces? Well, there's 4 aces in a deck of cards, and there are 52 cards in a deck. So the probability would be 4 divided by 52. You could also reduce that. And that would be 1 out of 13. You can also call that a decimal. So you've got all those. I'm going to just round this right here to about that. There's more to that, but we're not gonna go there. So that's basic probability. Probabilities are always between, in fraction form, 0 and 1. If something has 0 probability of occurring, it is impossible to occur. If it has if it's got a 1 chance of probability, then it is going to occur. So we're always between 0 and 1. If you look at converting this to a percent, and sometimes we look at those in percent form, this would be 7.69. Of course, rounding happens. So if you think in the percent land, it's between 0% and 100%. But all 4 of those represent a probability. So what we're interested in right now is a probability distribution. So a probability distribution depends on the idea of a random variable, something that happens at random. A random variable is a function. Remember, function is the idea of f of x that assigns a real number to each outcome of an experiment. The probability p of x, okay, p for probability, of each outcome x. So your input value is x, your output is the probability of that particular outcome. Just a quick review of the idea of probability. So when we look at the distribution, the probability distribution, what we're looking for is the p of x. So a probability distribution takes an event and breaks down the possibilities into probabilities. This data is then put into a table or a histogram, which is just a modified bar graph, to display. So what we want to do is an example of that. So we're going to use a sack of, or I guess a bag of M&Ms. So suppose a fun-sized bag of M&Ms contains 9 brown candies, 6 yellows, 7 reds, 4 oranges, 2 greens, and 2 blues. Make a probability distribution and draw a histogram. So personally, I think the easiest way to handle this is to make a table. All right, so I've got the number of outcomes that each one of these things can happen and the probability of each. So what goes across the top? The thing that goes across the top is the choice. So I'm going to put my blue colors. I'm going to have my yellow. I'm going to have my red. I'm going to put OR for orange so that doesn't look like a 0. I'm going to have green M&Ms, and then we will have blue. And I think we're going to have to call this brown, because brown and then the blue. Okay, so we've got the colors that can happen. The number of browns in a bag would be 9. The number of yellows is 6. The number of reds is 7. Number of oranges is 4, 2 greens, and 2 blues. So the way you calculate that, you don't have to put all of this in the table, but I like to make a table of steps. So if there are, it doesn't tell us the total, but if it doesn't do that, then we merely just have to add these values together. And when we add those up, let me introduce a notation to you. This is a sigma, and it typically in mathematics means sum, so we're just going to add some things up. So when we'll do that, you'll find that we have 30 M&Ms. So there's 30 total in there. So I'm going to have 9 over 30, 6 over 30, 7 over 30. This is the fractional probability. 2 over 30, 2 over 30. Now, typically what we do, you can reduce, but we tend to look at these in the decimal form for some reason or another. So if I want to convert that, then my decimal form, so the x's is the each outcome that can possibly happen for each color of M&M, and your probability function is the proper fraction that represents that, just like I did with the cards above. So when we do the division here, and I'm going to round to the nearest, if I need to round, I'm going to round to the nearest, I think, 2 decimal places. Okay, but yes, fractions are all okay as well. So now what you notice, you've got your input. This is your input values. These are your outputs. All right, so then all we're asked to do now is make a probability distribution. In other words, we're just going to show how this is distributed across a coordinate plane and in graphical form. Okay. The y, the output, is your p of x. The x-axis is your number of outcomes. So what I want to do is kind of break up the probabilities as best I can. So the 0.07 is the smallest. I'm pretty bad about not drawing things to scale. I just want things separated enough that so we can see a perceived difference. So that's 2.3. That actually should, excuse me, 0.23. That actually should be a little bit closer to the 0.2, but that's okay. Let me get this off here so that it, oops, I did it again. There we go. Let's make it look like that. Okay, and then we've got a 0.3 or 3/10. So given that idea, and again, treat this just like a y-axis. You start from 0 and work your way up. So then I'm going to have my outcomes. So I've got 2, I've got 2, I've got 4, I've got 6, oops, I've got 6, I've got 7, and I've got 9. Okay, so the x-axis just is labeled here with your numbers of outcomes here. So for 2 M&Ms, now the way you draw this, you don't start from the y-axis. You're going to go right here and let that 2 be in the middle. Okay, so that top value represents 0.07. And there's the same thing here. So notice the way you draw your histogram, and it's a picky thing in mathematics, you're going to be equidistant from either side of this value you're looking at. Why am I writing 0.07 on top of the rectangle? I like to do that for clarity, and I'm just going to fill it in a little bit just to make it stand out, kind of like I had colors. So with 4, I'm at the 0.13, so I'm going to go from here. And notice that I make my rectangles touch. That is the nature of a histogram. Bar graphs are not touching here, but histograms are. So this is at 0.13. My 6 is at 0.2. My 7 is at 0.23. Oops, get back down there just a little bit better. And then at 9, we would be at 0.3. And 3/10. So what you have just drawn, this is a probability distribution. This is the number. You always want to label what your values represent. This is the number of colors in the M&M bag, or the number of colored candies. And then, of course, this is the probability. This goes ahead and labels that axis, but you do need to label this. And so what we've got is a probability distribution.